Hey everybody, today we are going to do another differential equation problem, and today we are going to do which is called a variation of parameters problem, right? In other words, we are going to use the variation of parameters to solve differential equations, right? So now what we are going to do is we are going to follow some steps, right? So step one, okay. First of all, we doing 4.6 in this book, a first course in differential equation with modeling application by Dennis G. Seal, right? The same book that that we use. So now I'm going to explain the steps a little bit, right? In step one, we find a complementary solution, right? And we find the complementary solution by letting the left side of the differential equation equal 0. In other words, we are going to find the complementary solution of the differential equation by letting the left side equal to 0. In other words, we will treat it as a homogeneous differential equation, right? That is the first step. Second step, we are going to find the Wronskian, right? We are going to find the Wronskian. And then step 3 is we are going to find W1 and W2, right? And in step 4, we are going to find U1 and U2, and then we are going to in step 5 we are going to add the complementary solution plus the particular solution, which is going to be y is equal to y sub c plus y sub p. That is going to be the final answer for the differential equation, right? But we are going to treat the first step right here is to treat the left side of the differential equation as a homogeneous, right? So we're doing problem number 1 in this book. In problem number 1, right? But you know what? Before we get started with this, I'm going to explain a little bit of the formulas that we are going to use, because the board is not big enough for me to write everything down, right? I am going to be writing formulas and erasing them up so I can have some room on the board, right? The first step to find the Wronskian, is going to be W is equal to the determinant of y1, right, y2, okay, over the derivatives, okay? In other words, the derivative of y1 is going to be y1 prime, right? And the derivative of y2 is going to be y2 prime, right? So that's going to be the Wronskian, right? The Wronskian is going to be that, right? Now we are going to find the U1 and W1 and W2, right? Now W1 and W2 is going to be as follows. W1 is going to be equal to the determinant of 0, okay, over f of x, okay, and then y2 over here, right, over y2 prime, right? So okay, so notice that the f of x is whatever we get when the differential equation is given to us, whatever is in the right side of the differential equation is f of x, right? Now, to find W2 is going to be y1 over y prime, y1 prime, right? And then over here I get 0, and then I get f of x. Okay? So notice that over here, remember that when you do this, okay, make it sure that you have in this order, okay? If you put 0, you put f of x in the bottom, okay? And if you put, in this case, for W2, you get y1, y1 prime, and then you get a 0, and on the bottom you got f of x, right? Notice this, that when, okay, I forgot to mention something right here. This should be over the Wronski, okay? This should be over the Wronski, right? Now, notice that when I take the determinant of this time this is 0, this time this is going to give me a negative because I am subtracting it, right? I am subtracting it. If y, because y2 is positive, so when I multiply f of x times y2 and I subtract this diagonal right here, I'm going to get a negative, right? I'm going to get a negative. Okay, so if I do this is going to be a positive, right? Because I am subtracting this. So y1 prime times 0 is nothing, right? It's 0. So I am going to just multiply y1 times f of x, right? So this is positive. So always, remember this, always W1 is going to be negative. Always W1 is going to be negative and W2 is going to be positive. Remember that. Okay, so now I am going to the formula for y sub p is going to be equal to u1 of x plus y1 of x, right? I'm sorry. Y sub p is equal to u1 of x times y1 of x, right? Plus u2 of x times y2 of x, right? So this is the formula for y sub p. Okay, so y sub c, I don't even have to go in a lot of details because y sub c is very simple. All we gotta do is let the left side equal to 0, and then we find the complementary solution, and that's it, right? So so let me erase this, and we will try to do number 1 on this book. Number 1 is a very challenging problem in this book because it is pretty much a little bit of everything. We have a little bit of trigonometry involved in problem number 1. Okay, so I'm going to erase the steps, and I'm going to write the problem up. So problem number 1 is y double prime plus y equal secant of x. Okay? Okay? So notice that the secant of x is f of x, the one that I was talking about, right? Now, to find the complementary solution, all I gotta do is I'm going to rewrite this as a characteristic solution. Characteristic equation, and then I'm going to make it equal to 0. So the left side of this is going to be y double prime plus y equals 0, right? Notice that I have now I have a homogeneous differential equation ready, right? I have it equal to 0. So now what I'm going to do, I want to change this from this equation to a characteristics equation. So the characteristic equation is going to be r. Sorry about that. It's going to be r squared plus 1 equals 0, right? So what happened when I subtract 1, right? And I get that r squared is equal to negative 1, right? So if I take the square root on both sides, what do I get? I get r is equal to plus or minus I, right? Which means that the complementary solution is going to be y is equal to c1 cosine x plus c2 sine x, right? So that is y sub c, right? Okay. Now I am going to use y sub c to find the Wronskian, right? Okay. Very, very important. Very, very important that I am going to label this y1 and this y2, right? So now what I'm going to do is I'm going to set it up. y1 is cosine x and y2 is sine x, right? Now I'm going to take the derivative sign as negative derivative cosine is negative sine, right? The derivative of sine is cosine, okay? Okay, now take the determinant. When I multiply cosine times cosine is cosine squared, and when I multiply negative sine times a negative sine is negative sine squared. But remember that I am subtracting the negative sine squared. When I subtracted the negative sine squared, that becomes a plus. So the Wronskian over here is going to be nothing but cosine square of x plus sine square of x, which is equal to 1, right? One of the trigonometric identities. Okay, so let me erase this so I can put this stuff over there, right? So I know that y sub c is equal to is equal to cosine of x, c1, right? Cosine of x plus c2 sine of x, right? And I know that the Wronskian equal 1, right? So now that I know that the Wronskian is equal to 1, I'm going to find W1 and W2. So, well, W1 is equal to 0, right? I put 0 and I put secant of x, right? So secant of x can be written as 1 over cosine, right? So secant of x can be written over 1 over cosine of x, right? Then over here, I can, y2 is belong here, right? So what is y2? Y2 is sine, right? This is y2, sine of x. This is y1, right? So y2 is sine of x, okay? And then, what is the derivative of sine? Is cosine, right? Okay? But again, it doesn't really matter because cosine, 0 times cosine is 0, right? But over here, notice that if I do this, if I subtract this piece right here, okay? When I subtract this, I get negative sine of x over cosine of x, right? Which is nothing but negative tangent of x, right? So this is W1. Okay? Now W2. W2 is going to be now notice that I am switching it. Okay? Whatever is W2, I'm going to substitute with 0. Okay? So I gotta have I gotta have y1, right? What is y1? y1 is cosine, right? Cosine of x, right? And what is y2? Well, y2 is supposed to be substituted by 0, so I put 0 in there, right? And then below 0, we get the secant, right? Secant of x can be written as 1 over cosine. 1 over cosine of x, right? The derivative of sine, the derivative of cosine is negative sine, right? Okay? Again, this times that is 0. Okay? It's nothing. We only have a W2. We have cosine of x over cosine of x, which is equal to 1, right? So W2 is equal to 1. Okay? Now, now that I have this W1 and W2, I can actually integrate, okay? And I can say that u prime is equal to u1 prime is equal to W1, right? And W2 prime is equal to W2. I'm sorry, U2 prime is equal to W2, right? Now, I'm going to integrate W1 and W2, right? So, okay, so let's say that U1 prime is equal to negative tangent of x, right? If I integrate this, what do I get? So the so the u prime just become u1 prime just become u1, right? And then the tangent, the negative tangent of x becomes, remember that the integral of tangent is nothing but the ln of absolute value of cosine x, right? Well, if it's the integral of the tangent is the negative ln absolute value of cosine x, right? So if I do that, then I'm going to have negative ln of absolute value of cosine x, right? Okay, so that becomes nothing but ln of absolute value of cosine x, right? That is that is u1, that is u1 prime, right? Now, notice that I am going to find W2. So what is W2? I'm sorry, U2, right? So U2 is equal to U2 prime, right? Is equal to 1, okay? Okay, so now integrate on both sides because this W2 is equal 1, right? So U2 is equal to 1. If I integrate on both sides, what do I get? I get U2 is equal to X. Okay? Excuse me. So now look at this. Look at this, that the answer, the final answer is going to be as follows. Okay? The final answer is going to be as follows. Okay? I'm going to multiply U2 times Y2, and I'm going to multiply U1. I'm going to multiply U1 times Y1, I'm sorry, and I'm going to multiply U2 times Y2, right? So the formula for this is in the bottom of this book, okay, which let me just rewrite the values that I have, right? So because I am going to use those. Okay, I have U1 is equal to ln of absolute value of cosine x, right? And U2 is equal to x, right? So let me just clear this up. Okay? And the formula is as follows. Yp is equal to U1 times x, right? U1 times x times Y2 times x plus, sorry, U1 times x times Y1 times x plus U2 of x times Y2 of x, right? So this should be the formula for Yp. That is the formula for Yp, right? Now, I am going to take U1, right, and multiply times that, right? And I'm going to multiply U2 times that, right? So Yp is equal to, notice that I am only dealing with the cosine and sine now, and I cannot bother writing C1 and C2 because C1 and C2 is only part of the complementary solution, right? So I'm going to have ln, right? Absolute value of cosine x times cosine x plus x times sine x, right? So when I do that, when I clear this up, I get just yp is equal to ln of absolute value of cosine x. Actually, you know what? This should be written in front, okay? Cosine x times ln absolute value of cosine x plus x, right, times sine x, okay? Now, what I'm going to do, I'm going to combine y's of p with y's of c, right? So I'm going to so y is equal to the y sub c plus y sub p, right? So the final answer for this is going to be as follows. It's going to be y is equal to y sub c, which is going to be c1 cosine x, right? Plus c2 sine x, right? Plus this bit right here, right? Which is going to be cosine of x ln of absolute value of cosine x plus x sine x. That is the answer. That is the answer for this problem. Okay? So, the book might have this at the end, but it's the same thing. Okay? You can write with this x sine x first, and this cosine times the ln of x, ln of cosine x after. It doesn't really matter, right? As long as you have the y sub c plus y sub p, that makes the right answer. That's it for this problem. I hope this helps somebody who is taking differential equation. Thank you. All right.